This is the screencast for section 4.1, example 2. Now we're going to learn what a radian is. Your book's definition of radian says that it's a central angle of a circle that has a measure of 1 radian if it intercepts an arc with the same length of its radius. So they use this diagram right here. Basically, if you take the radius and wrap it around the edge of the circle or the circumference of the circle, that 1 radius, if you connect it to the center, that angle is 1 radian. Now notice what I said. You take the radius and wrap it around the circumference. Now what is the formula for the circumference of a circle? Circumference is 2 pi r. Well, that's because there are 2 pi radiuses in one circle. You can do this 2 pi times, which also means there are 2 pi radians in one circle. 2 pi radians, not 2 radians, 2 pi radians. So if you think about that numerically, it's 2 times 3.14, which is about 6.28. So looking at this circle, you've got your first radian, your second radian, your third radian, your fourth radian, your fifth radian, your sixth radian, and then your 0.28-ish radian. 6.28 all the way around, or 2 pi radians in one circle. There are 360 degrees in a circle, but there are only 2 pi radians. Now 2 pi is kind of the natural course that circles take. 2 pi comes from the ratio of a circle's radius to its circumference. So much like how you, as you've been going through science class have had to think of inches and feet and, I don't know, yards and miles, and now are starting to think of millimeters and centimeters and meters and kilometers or grams, converting to the metric system, you are going to have to start thinking in radians. So that's what example 2 is about. The book tells you that you can convert from radians to degrees by multiplying by 180 over pi, or you can convert from degrees to radians by multiplying by pi over 180. Those are fine if you want a quick way to memorize how to convert, but like I said, I want you to be thinking in radians, so I'm going to show you a couple ways in example 2, and it's now try problems, to go at this a little bit differently. So what I'm going to do is I'm going to take a circle and I'm going to put it on the coordinate plane so I can divide it into 4 parts and kind of have a frame of reference where everything goes. I'm going to start here on the positive x-axis and call that 0 degrees, which is also 0 radians, which we said all the way around, we get back to that same spot, is going to be 360 degrees, or 2 pi radians. Well, over here is going to be pi radians. So halfway to 2 pi radians would be pi radians, and that would be 180 degrees. So now I'm looking for a 90-degree angle, which is this angle right here, which is a quarter of the way around to 2 pi, or halfway of the way to pi. So this is pi over 2 radians, which is 90 degrees. Now part B asks us how many degrees are in pi over 3 radians. Well, I'm going to look at it this way. Same thing. I have 0 radians here and pi radians here. 0 radians is 0 degrees. Pi radians is 180 degrees. I'm looking for pi over 3. So I'm looking for a third of the way to 180 degrees. So if I take the distance between 0 and pi, divide that into thirds, I'm looking at 60 degrees, 60 degrees, and 60 degrees. So pi over 3 radians equals 60 degrees, a third of the way to 180 degrees. Now part C, find the length of an arc intercepted by a central angle of 1/2 radian in a circle of radius 5 inches. So I'm going to draw that first. I've got a circle it's got a radius of 5 inches. Now the central angle is 1/2 of a radian. Well, I know that 1 whole radian would be 5 inches. So 1/2 of a radian would be 5/2 inches, which is 2.5 inches. Remember, 1 radian would intercept our whole radius, so half of a radian is going to intercept half of our radius. Part D, find the radian measure of a central angle that intercepts an arc length S in a circle of radius R. Okay, so now they're throwing a curveball out here. I don't know what that's going to be. So I'm going to look at, let's see, I've got a radius R and an arc length S that I don't know. Well, if I go back to part C, what I did was I took my radius and I multiplied by how many radians I had, 1/2. So my arc length here, S, is going to be my radius times my angle. How many radians I have, which we call theta. And this is actually your formula for arc length. In the Now Try problems, numbers 11 and 19, I'm going to show you a more arithmetic way, old school algebra, which might be a little bit more straightforward for you, but isn't necessarily going to help you with how to think in radians like the previous examples will. So in exercise 9 through 16, convert from degrees, minutes, and seconds to radians. I know right off the bat that there are 180 degrees in pi radians, or 360 degrees in 2 pi radians. That would reduce to 180 degrees in pi radians. So then if I just set up a proportion, I have 120 degrees in x radians, cross multiply, leave pi as pi, don't erase that, and then, or don't write it out as 3.14 or whatever. Divide both sides by 180, and I get x equals, simplify that, that would be 2/3 pi, which is 2 pi over 3. Now, if I were thinking about it the way I described in the previous examples, again, I've got a circle who has 0 radians here and 2 pi radians here, which is also 360 degrees. 180 degrees is over here along with pi radians. I'm looking for 120 degrees. So 120 degrees is past 90 and not quite to 180. It's actually 120 degrees, so this is 120 degrees, is about 2/3 of the way to pi radians. So this would be 2 pi over 3. Number 19, convert from radians to degrees. So I can use my proportion way. I know that there are 180 degrees in pi radians, and I'm looking for how many degrees are in pi over 10 radians. So if I cross multiply, I have 180 times pi over 10 equals pi times x. Let's see, so that would be 18 pi equals pi x. Divide both sides by pi, and I have 18 equals x. So I've got 18 degrees in pi over 10 radians. So thinking about our circle again, here is 0 or 2 pi radians, which is 0 or 360 degrees. And then here is 180 degrees or pi radians. Now pi over 10 is 1/10 of the way to pi radians, so 1/10 of the way to half a circle. Well, 1/10 of my way there, pi over 10, would be 18 degrees. 1/10 of the way to 180 degrees.